If you've ever run a batch of accounts through an anti-detect browser and watched one of them get challenged for no clear reason, while an identical looking profile sails through clean, there's a good chance Cloudflare is the thing doing it. I run proxy infrastructure and cloud phone farms for a living, and I test anti-detect browsers hands-on against real multi-account setups, not against a demo login screen with one clean tab open. This video is what I've actually learned watching that traffic hit Cloudflare day after day across different sites and different thresholds. Cloudflare bot management sits in front of a huge share of the web, so if the site you're logging into runs through Cloudflare, and a lot of them do, every single request you send passes through this system before it ever reaches the site's own servers. You never see it directly, but it's scoring you the entire time. It scores each request and each visitor, then decides whether to let you through quietly, throw a challenge at you like Turnstile, or block you outright before the page ever loads. That score is the actual thing deciding whether your session survives. Not the login form, not the password, the score. If you run multiple accounts through tools like multilogin, GoLogin, Camelio, AdsPower, or Dolphin Anti, you've probably run into this already in one of a few familiar shapes. A turnstile challenge that spins and never clears no matter how many times you solve it. A page that loads but quietly serves a stripped down or broken version of itself, or an account that gets flagged and locked within minutes of its very first login, before you've even done anything with it. Understanding what's actually being measured tells you which parts of your setup an anti-detect browser can genuinely influence, and which parts it simply cannot touch, no matter how good the tool is. That distinction is the whole point of this video, because most of the confusion I see comes from people assuming the browser is the entire story. Cloudflare doesn't rely on one check to make that call. It stacks several independent layers on top of each other, and each layer is built to catch a completely different kind of tail. So a setup that cleanly passes one layer can still get caught cold by the next one down the stack. The first layer happens before your browser has sent a single byte of actual HTTP traffic. It's the TLS handshake, and the order and content of that handshake, the cipher suites offered, the extensions listed, the elliptic curves supported, all of it forms a fingerprint known as JN3, or its newer successor JN4. That fingerprint is generated by the TLS library your HTTP client happens to be using, not by anything a browser extension or a spoofed setting controls. A real Chrome build running on Windows produces a consistent, extremely well-known JA4 signature that Cloudflare has seen billions of times across billions of sessions. A scripted client built on a generic HTTP library, or an automation stack that never bothered patching its own underlying network stack, produces a different signature entirely, even while the user agent header cheerfully claims to be the latest Chrome on Windows. And Cloudflare simply checks what it actually sees on the wire against a running library of known good and known bad fingerprints. Separately from TLS, the way a client frames its HTTP/T requests, the stream priorities it sets, the order of its headers, the size of its frames, leaves an entirely different fingerprint of its own. Real browsers implement HTTP/2 in a specific, highly consistent way that barely changes across versions. A lot of automation frameworks, especially older ones built on plain HTTP libraries or on Chromium builds where someone tampered with the network stack but forgot the HTTP/2 layer, get this wrong in ways that flatly contradict what they're claiming to be in their own user agent header. Then there's IP and SN reputation, and this single layer is the one that catches the most multi-accounting operations by far, and it has nothing whatsoever to do with the browser sitting on top of it. Cloudflare maintains ongoing reputation scores per individual IP address and per SN, which is just the network block that IP happens to belong to. Data center IP ranges, well-known VPN exit nodes, and heavily reused proxy pools all score worse by default, regardless of what browser fingerprint happens to be sitting behind them that day. Mobile and residential IP ranges tend to carry a better baseline reputation simply because real consumer devices live there. But even a mobile or residential IP gets burned fast if the same handful of addresses get cycled across hundreds of accounts. A completely pristine browser profile running over a flagged data center IP still gets challenged constantly because the network layer signal outweighs the browser layer signal every single time the two conflict. The last layer is behavioral and environment signals, and this is the one that's actually hardest to fake convincingly over a long session. Mouse movement entropy, natural scroll behavior, typing cadence if there is any text entry at all, the timing gap between page load and first interaction, whether the JavaScript execution actually matches what a genuine browser engine produces under the hood, and what the canvas and WebGL rendering pipeline physically outputs on that specific machine and that specific GPU. This is the one layer that's genuinely entirely about the browser itself, and it's where anti-detect browsers pour most of their engineering effort, for good reason, because it's the layer they can most directly control. All four of those layers roll up into a single bot score, running from 1 to 99, that Cloudflare exposes directly to the site owner, where a lower number generally means more likely automated. Site owners then set their own thresholds for what gets a soft challenge, what gets a hard block, and what gets a clean silent pass, which is exactly why the same identical setup can behave completely differently from one site to the next. So where do anti-detect browsers actually earn their keep in all of this? Their real job is to make the browser-side fingerprint, canvas output, WebGL output, installed fonts, screen dimensions, time zones, dozens of navigator properties, and in the better tools, the TLS and HTTP/2 stack itself look like a normal, internally consistent real browser profile. And just as importantly, to keep that exact profile stable across sessions so the same identity doesn't quietly drift between one login and the next. That's genuinely useful engineering work, and there's a meaningful gap between tools that patch things properly down at the browser engine level and tools that just override a handful of JavaScript readable properties and call it a day. A profile that reports a perfectly consistent user agent string but leaks its real TLS fingerprint through an unpatched network stack underneath is exactly the kind of mismatch Cloudflare was specifically built to catch. And honestly, it's a common failure mode in cheaper or older automation tooling that hasn't kept pace with how detection has moved on. I've watched profiles that looked flawless on every JavaScript level property still get flagged within a single session because of exactly this gap. What none of these tools can fix for you, no matter how well built, is your network layer. If you're running 20 browser profiles over the same residential IP, or over shared data center proxies, or over proxy pools that dozens of other operators are also cycling through around the clock, the IP reputation signal works against every single one of those profiles, no matter how clean the browser fingerprint underneath happens to look. That's the actual reason proxy quality and browser fingerprinting keep getting talked about in the same breath by people who actually run this stuff. They're two fully independent layers of the same detection stack, and scoring well on one layer does not compensate for scoring badly on the other. Cloudflare weighs them separately and stacks the results. And see this exact pattern play out every day running proxy infrastructure, both mobile and residential. A clean, well-maintained browser profile sitting over a dedicated low-reuse IP behaves completely differently from that exact same profile sitting over a shared or recently burned one, even though the browser side hasn't changed a single setting. I've swapped nothing but the IP under an otherwise identical profile and watched the same login go from a clean pass to a repeated challenge. Neither half of that equation is optional, and treating one as more important than the other is where most setups quietly fail. So here's the honest version of all this without overselling any single piece of it. No anti-detect browser makes an account undetectable or unbannable. Full stop, and anyone telling you otherwise is selling something rather than describing something they've actually tested. Bot management is a scoring system, not a fixed lock, and platforms adjust their thresholds and retrain their detection models over time, sometimes without any public announcement at all. So a setup that scores comfortably well today can score noticeably worse next month once the underlying model quietly shifts under it. The tools that hold up better in practice, from what I've actually tested, are the ones patching fingerprinting down at the browser engine level, a genuinely consistent TLS and HTTP step, coherent canvas and WebGL output, matching hardware concurrency and device memory values, rather than the ones that only override a few surface properties a script can read straight off Navigator. You can check a good chunk of this yourself on public fingerprinting test pages before you ever trust a tool with a real account. For the event, 48 matters just as much as raw profile quality on its own, a profile that quietly changes its reported time zones, language, or screen resolution between sessions is actually a bigger tell than one that's slightly unusual but stays perfectly stable session after session. Because consistency itself, not just plausibility, is one of the behavioral signals Cloudflare's model is directly weighing every time that profile shows back up. And none of this replaces actually understanding what a platform's own terms of service allow in the first place. Bot management exists in the first place because platforms decided certain automated or duplicate account behavior breaks their rules, and clearing a technical challenge doesn't change that underlying policy one bit. It just means that particular request got through this time. So here's the bottom line on all of it, the whole stack in one breath. Cloudflare bot management is layered. TLS and HTTP fingerprinting sitting at the network level, IP and ASN reputation sitting at the infrastructure level, behavioral and rendering signals sitting at the browser level. Anti-detect browsers operate almost entirely on that last layer, and they can be genuinely well engineered or genuinely sloppy about it. And that difference shows up the moment a TLS handshake doesn't match the browser it claims to be, or a canvas output comes back as an obviously synthetic, flat value. But even the best browser layer engineering in the world still sits on top of whatever your IP reputation already says about you before any of that browser work even gets evaluated. So judge these tools on the parts of the stack they can actually control, and don't expect the browser alone to solve what's partly, honestly, a networking problem. I test these browsers on real multi-account setups, so the written reviews and the picks I actually trust are all at antidetectreview.org. Full written reviews and tested picks at antidetectreview.org, and hit subscribe if you want the next breakdown.